In this video, we will be seeing how to use a binomial formula to calculate the chances of an event occurring. First, let's review what it means to be a factorial. We're going to answer the question, what is 7 times 6 times 5 times 4 in factorial notation? 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. This expression up here is almost that, but we are missing the 3 times 2 times 1. This is 3 factorial. Then 7 times 6 times 5 times 4 is 7 times 6 times 5 times 4 times 1, which we can write as 3 factorial over 3 factorial. Then we have 3 factorial in the denominator and in the numerator. We now have 7 times 6 times 5 times 4 times 3 times 2 times 1, which is 7 factorial. So our answer is 7 factorial over 3 factorial. Now here's the real question. A die is rolled 12 times. What is the chance of getting exactly 3 4s? This requires the use of the binomial formula. And let's recall what the binomial formula is. It is the binomial coefficient, which is n factorial over k factorial times n minus k factorial times 1 over p to the k times 1 minus p to the n minus k. Here n is the number of trials, k is the number of times the event occurs, and p is the chance of the event occurring in a single trial. Now, in order to use the binomial formula, certain conditions must be made. The number of trials must be fixed, the rolls must be independent, and the chances of something occurring cannot change from trial to trial. This particular question satisfies all of those conditions. The number of trials, n, is fixed at 12. We roll the die 12 times, no more. The probability of the event occurring of getting a 4 is 1 out of 6. This isn't going to change no matter how many times we roll a die. And that leaves our variable k. K is the number of times the event occurs. So how many times do we want to get a 4? We want to get 4 3 times. Now we plug that into the formula. That is 12 factorial over k factorial, which was 3, times 12 minus 3 factorial, that's n minus k factorial, times 1 over 6 to the k times 1 minus 1 over 6 to the n minus k, 12 minus 3. Let's simplify this as much as we can. We get 12 factorial over 3 factorial times 9 factorial times 1 over 6. It wrote k, but it should be 3 here. To the 3 times 5 over 6 to the 9. 12 factorial over 9 factorial is equal to 12, let's do this in a different color. So this is side work here. This is 12 times 11 times 10 times 9 factorial. That's what 12 factorial is, and then we're dividing by 9 factorial, which means the 9 factorials cancel, and we're left with 12 times 11 times 10. So I'm working in this part right here, and I got that that was 12 times 11 times 10 over 3 factorial. Now 3 factorial is 6, you can check that out. What's good about that is it goes evenly into 12. 12 divided by 6 is 2. There isn't much we can do with the fractions that follow. We do have 5 to the 9, and then based on algebra we have 6 to the 3 times 6 to the 9, which can be simplified. So 2 times 11 times 10 is 220. Then we have 5 to the 9 over 6 to the 12. Now I have to plug this into a calculator. So do 5 to the 9, we do 5. Click the XY key to the 9 equals. And then we divide by 6 to the 12. Then we multiply that by 220. So we get 0.197395. In percentages, that's 19.7395%. Now, you do not have to go out to that many decimal places, and really we should round this to 6. And that is how you find the chances that you'll get exactly 3 4s in 12 rolls. If you have any questions, please ask in the questions and answers discussion board.